Today in this video we are going to explain theory of production, that is production function. We are aware that production of goods is essential to fulfill the demands of consumers. That is how the process of production goes on in every economy. What is meant by production in economics? Production is the transformation of resources. Resources are the inputs into commodities or outputs. For example, when we get wheat on a plot of land with the help of inputs like labor, capital, seeds, then plow or tractor, harvester, it is termed as production of wheat. Similarly, when in a cloth mill, inputs like labor, capital, and threads and machines are transformed into cloth, it is called production of cloth. As we produce physical goods in an economy, services are also produced. For example, services of a teacher, an advocate, a doctor, a singer, and servants are also called production in economics. So production means commodities, physical goods, as well as services. What are the factor inputs? Factor inputs are the resources needed to produce goods and services. For example, land, labor, machineries, capital, raw materials, etc. Now let us know the concept of product. Before analyzing the theory of production, it will be useful to study some of the basic concepts relating to product. There are three basic concepts of product: total physical product, TPP, average physical product, APP, and marginal physical product, MPP. So let us know their meaning and the behavior of these concepts. First, total physical product. Total physical product is the total amount of a commodity produced during a given period of time by a given number of factors of production. In other words, TPP means the total physical output produced by a given number of input, keeping all other inputs constant. How can we estimate the total product? Total product is the summation of MPP, or total product is average physical product multiplied by the number of units of variable factor. Now, TPP is the summation of marginal physical products of various units of a factor, and it is the average physical product multiplied by the number of units of a variable factor employed. The behavior of TPP. TPP first rises at increasing rate, then it increases at diminishing rate. After that, it remains constant at its maximum and finally decreases. Average physical product. Average physical product, it refers to the per unit output of a variable factor. That means average physical product is a factor, average physical product of a factor is the total physical product divided by the number of units of a factor. That means APP is equal to TPP by N. N is the number of units of a variable factor. What is the behavior of APP? APP first rises, then it remains constant at its maximum and finally decreases. One of the important features of APP is throughout the process Mpp remains positive, means Mpp is greater than 0. Mpp, marginal physical product. It refers to the net addition to the total physical product due to use of one more or less unit of the variable factor, keeping all other factor constant. For example, if you say that total product of 4 labor in one is 120 units and total physical product of 3 labor is 90 units, then the marginal product of labor is 120 minus 90 is equal to 30 unit of fourth labor. That means the fourth labor contribution is 30 units. How to calculate marginal physical product? Marginal physical product is equal to delta TPP by delta F, means change in total physical product divided by change in the number of units of variable factor. Mpp can be estimated in the alternative way also. Mpp is equal to TPP of nth unit of the variable factor employed minus TPP n minus 1 unit of variable factor. What is the behavior of Mpp? Mpp first rises, then it remains constant at its maximum and finally decreases. But Mpp can be positive, 0 or negative. Production function. The technical law relating inputs to output has been given the name of production function. So it is a purely technical function. In economics, the production function is a technological relation showing for a given state of technological knowledge how much can be produced with given amount of input. In other words, we can say it expresses the technical relationship between the physical inputs and physical output of a firm for a given state of technology. Mathematically, production function can be expressed as Qx, means quantity of good X, that is the production, is equal to function of F1, that is the first factor of production, second factor of production F2, third factor of production F3, and dot 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 Fn, that is the nth factors of production. Types of factors of production. Factors of production are of two types: fixed factors and variable factors. Fixed factors are those factors which do not vary with the level of output. Means if the output increases or decreases, there will be no change in the fixed factor, such as land, building, machinery, this. If you produce 1, then also the same. If you produce maximum, then also these factors remains constant. And these factors occur only in the short run. So the existence of fixed factors only in the short run. Variable factors are those factors which vary with the level of output. Means as we increase the level of output, the employment of variable factors will also increase. So it varies with the level of output. More output means more factors, variable factors. Less output, less variable factors. Variable factors occur both in short run and long run. Short run means there are two types of factors of production, variable and fixed. But in long run, the factors of production are of only one type and all factors are variable factors in long run. What are the variable factors? For example, labor, raw materials, power, fuel, etc. Types of production function. Production functions are of two types. Short run production function, which is also known as law of variable proportion or law of returns to a factor. When more and more units of a variable factor are employed, keeping other factors constant, TPP first increases at increasing rate, then increases at diminishing rate, and finally decreases. This occurs in short run, and this is called law of returns to a factor. Long run production function or law of returns to scale. It refers to the change in output when all factor inputs are changed in the same proportion. So there is a difference between these two. Here the factors are changed in the same proportion, but in this case the ratio between variable factors and fixed factor keep on changing. That's why it is called variable proportion. The ratio between fixed and variable factors changes because one is constant, the other is increasing. So at every time the ratio will change. Now we'll explain the relationship between TPP, APP and MPP. We'll also know how to construct these curves and how to construct production possibility schedule. At the beginning, just recall the behavior of MPP. MPP first rises. After reaching its maximum, it decreases. While decreasing, first it is positive, then 0 and finally negative. That is the MPP's behavior. Now this one will apply in the table. First will increase, then it will decrease. After reaching maximum, it will decrease. Positive values, 0 and finally negative. Let us see this table. Fixed factors, because other factors are fixed. Only one variable factor, let us assume labor. Fixed factor, land 1 acre, all are constant. Variable factors, labor 0, 1, 2, 3, 4, 5, 6, 7, 8. Now we have, first we have to assume this MPP. 0 MPP is undefined. So 1 MPP considered 2, the next is 4, then 6. So 2, 4, 6 it is increasing and 6 is the highest value of MPP. This is the maximum value. Then it starts to fall and it becomes positive. 6, then 4, 2, these are the positive values. Then it becomes 0. Then finally negative. So we have got the behavior of MPP. First it rises, reaching maximum, then it starts to fall. While decreasing, first it remain positive, then 0 and finally negative. Now from MPP we can calculate TPP because TPP is equal to summation of MPP. So first one TPP, when the variable factor is 0, the production will be 0. Even if you have all the fixed factors and variable factor is not there, then production will 0. So at 0 level of variable factor, production is 0. 1 unit TPP is how much? Summation of MPP. So 2 units of employment, 2 plus 4, 6, then 6 plus 6, 12, then 12 plus 4, 16, 16 plus 2, 18, 18 plus 0, 18, 18 plus minus 4 is 14 and 14 minus 6 is 8. So TPP you have calculated. Then how to calculate the APP? APP is equal to TPP by variable factor. Here labor means TPP by L. So first one undefined, the second one 2 by 1 is 2, 6 by 2 is 3, 12 by 3 is 4, 16 by 4 is 4, 18 by 5 is 3.6, 18 by 6 is 3 and 14 by 7 is 2 and 8 by 8 is 1. So APP you have calculated. Now see the APP's behavior. APP first rises, then remains constant at its maximum. So the maximum value is 4. Then it decreases. But throughout the process, APP you see the positive greater than 0. APP will be greater than 0. MPP's behavior we know. As long as MPP rises, TPP will increase at increasing rate. So up to 3 units of employment of variable factor, TPP increases at increasing rate. Then when MPP decreases but positive, TPP increases at diminishing rate. So rate is decreased to 12 to 16, 4 increased, and then 16 to 18, 2 increased. So it is decreased. Then at 0, TPP becomes maximum. When MPP is 0, TPP maximum. So this 18 is the maximum value, occurs at 6 units of employment variable factor. Then when MPP becomes negative, TPP declines. 18, then 14, then 8. In the next, we'll explain these stages later on. In the next video, we'll explain the production, that law of variable proportion, its causes, and the meaning of each stage. Now let us see how to construct the TPP, APP and MPP curve. First we'll draw the MPP curve. So MPP first rises up to here and then it decreases, and at this level it becomes negative. We know TPP starts from 0 as long as MPP rises. So MPP rises up to L1 units. Then TPP increases at increasing rate up to here. Then when MPP decreases but positive, then TPP increases at diminishing rate. This is the diminishing rate. And this is the point, that the curvature. This is called point of inflection. The curvature of TPP is called the point of inflection. At this point, TPP stops increasing at increasing rate and starts increasing at diminishing rate. This is the point of inflection. Now at this, MPP intersects x-axis, means MPP is equal to 0. At this level, TPP's value is maximum. This is the maximum. If you draw a tangent, we'll find at this point tangent point of tangency, and this is the TPP maximum level. After that, MPP, when MPP becomes negative, TPP declines. This is here it is given. When MPP increases, TPP increases at increasing rate. When MPP decreases but positive, TPP increases at diminishing rate. When MPP is 0, TPP is maximum, constant at its maximum, and when MPP decreases negatively, then TPP decreases. Now let us see APP. APP first increases, then after reaching its maximum, it decreases, but it remains in the positive zone. Means APP is always positive. We'll find the relationship between APP and MPP. If you see here, as long as APP rises, that is up to here, if you consider any point, if we give L. So before L, MPP curve lies above APP. That means as long as APP rises, MPP is greater than APP. At this point, APP is maximum. At maximum point, you see MPP intersects APP. That means at the maximum point of APP, MPP is equal to APP. The value of MPP is equal to APP. And when APP decreases, MPP curve lie below the APP curve. That means MPP is less than APP. Now see this, what we have said. If we see the previous table, as long as APP rises up to here, rises 4 is the maximum, so up to here, the value of MPP is greater than APP. See, first starting both the same, but thereafter APP is 3, MPP is 4, APP is 4, MPP is 6. That means as long as APP rises, MPP is greater than APP. And this is the maximum point of APP. That is at 4 units, it occurs at 4 units of employment of labor, and the value is 4. and you find the same value is Mpp. That means at the maximum of APP, Mpp is equal to APP. Then when APP decreases, thereafter APP decreases, and if you see the value of Mpp is less than APP, that means when APP decreases, Mpp is less than APP. These are the three important relationships between APP and Mpp. So this relationship we have explained here. When Mpp rises, TPP increases at increasing rate up to 3 units of employment of labor, or OL in the diagram up to OL units of employment of labor. As long as Mpp decreases positively, TPP increases at diminishing rate. Before O6, that means before OL1 units of labor. When Mpp becomes 0, TPP remains constant at its maximum, and that occurs at 6 units of labor, that is OL1 there. And when Mpp becomes negative, TPP decreases beyond 6 units of labor, or beyond OL1, that is 7 and 8 units. APP Mpp, as long as APP rises, Mpp is greater than APP. When APP is maximum, Mpp is equal to APP. As long as APP decreases, Mpp is less than APP. And APP throughout the process is positive, whereas Mpp can be positive, 0 and negative. And point of inflection already we have explained. The point of inflection is the curvature of TPP at which TPP stops increasing at increasing rate and starts increasing at diminishing rate. That is called point of inflection, denoted as I in the previous diagram. If you see, this is the point of inflection. This is the curvature of the TPP curve. So we can construct the TPP, APP and MPP curve, or separately TPP and MPP curve and APP and MPP curve. I hope you will try to construct these two curves, TPP and MPP, and explain the relationship, and then in the separate diagram you will draw APP and MPP and state their relationship. In the next video, we'll explain the law of variable proportion. Thank you.